So I think I decided that we're gonna take a look at the unit circle in multiple parts. So we're gonna work our way up to obviously having to memorize this whole thing in a short period of time, like typically just a couple of days, you'll have to have it memorized. But instead, I'm going to take a look today at starting to develop where some of these things came from. So here's the unit circle. And if we just kind of zoom in here, trigonometry has to do with right triangle relationships. So I'm going to draw on a right triangle here. And in the unit circle, the radius is one unit. So in this case, if we look at the circle, there's the radius. It's the hypotenuse of this triangle. Now that 30 degrees is actually signifying it's this angle right here. So what I want to do is take a look at just that triangle for right now and see if we could figure out how is it coming up with these points. So from what we did yesterday with SOHCAHTOA, the 6 trig functions, we were finding different lengths of the sides. So if I were to call this value my y value, so that's a vertical up and down, so it makes sense it would be a y. And I'm looking at what trig function this uses. So opposite of 30 is the y, and then I have the hypotenuse. So in the whole SOHCAHTOA, the one that uses opposite and hypotenuse is our sine. So sine of 30 degrees is equal to opposite y over 1. So y over 1 is just y. So really I want to look at sine of 30 degrees. So if we put that in our calculator, remember the sine key is right there, and you have to make sure you're in degree mode. And if we hit sine of 30 degrees, we get it to be 0.5, which is 1/2. So y is 1/2. So I'm going to go ahead and replace that with 1/2. Now, if I wanted to find this missing side, and if I call that x, because that's kind of my horizontal distance, would make sense, I would be using adjacent, and I could use the 1 for the hypotenuse or opposite for the 1/2. But you end up getting an irrational number, kind of a crazy decimal. So instead of using the trigonometry functions, we're going to do Pythagorean theorem. So a squared plus b squared equals c squared. So x squared plus my 1/2 squared is equal to the hypotenuse, which is the 1 squared. So if I go to solve that, 1/2 squared, 1/2 times 1/2 is 1/4. So I'm getting x squared plus 1/4, and then 1 squared is 1. Subtract the 1/4 from both sides, and I'm getting 3/4. If I go to square root both sides, I do know I get a plus and a minus, but we're looking at a length of a side of a triangle, so it's positive only. Square root of 3 over 4. So square root of 3 doesn't simplify anymore, but the square root of 4 is 2. So we're getting that side to be square root of 3 over 2. So back to our triangle, we're getting square root of 3 over 2 is my x value, and then the y value was 1/2. And if we look at the unit circle, the x value was the square root of 3 over 2, and the y value was 1/2. we're going to look at that also kind of in reverse. So if I go different color over here, for this angle, so I'm skipping the 45 for right now. So for the 60-degree angle, I'll look at that triangle. And that 60 degrees, again, is right here. And the unit circle, the radius is 1. So that's that part. So if I take that and move it over out of the way where we could work with it. One thing to point out with that last triangle is all three angles have to add up to be 180. So we have a 60 and 90. This missing one is a 30. In our other triangle, that means that this one missing was a 60. So it's exactly the same triangle. So if we look, across from 30 degrees was the 1/2. That means over here, across from 30 degrees is your 1/2. Across from 60 is the square root of 3 over 2. Because up here, the one that we figured out opposite of 60 was the square root of 3 over 2. So those two values, this is still my horizontal distance, my x, and this is my vertical distance, my y, shows up here. There's my x, there's my y. So the 30 and the 60 are just flipped of each other. The x is the y and the y is the x. If we look at the 45-degree one now, it's a little different, but the same idea. Remember, these are supposed to be right triangles. Use your imagination. That's one. The 45 is that part right there. So if we take this and work with it somewhere, knowing that all three angles have to add up to be 180, this ends up being a 45-degree angle. Equilateral, those two angles are the same, so that means these two sides have to be the same. Thinking back to geometry, I'm just going to call those x, even though, yes, it's an x and a y, but I know those are exactly the same. So I'm going to do Pythagorean theorem to figure out what each of those are. So a squared plus b squared equals c squared. So you're getting 2x squared is equal to 1. Divide by 2 and you get 1/2. We then square root both sides. We're only worried about the positive because it's the length of a triangle. And we're getting the square root of 1, which is just 1, and then square root of 2. We can't keep that in the denominator, so if you think back to when we rationalized that, we multiplied by the square root of 2 over the square root of 2. And that then became 1 times the square root of 2, which is just square root of 2. Denominator, square root of 2 times the square root of 2 is square root of 4, which is 2. So those missing sides are each square root of 2 over square root of 2 over 2. And if we look at the 45 degrees, each of those are exactly the same, square root of 2 over 2. So everything on this unit circle actually comes from right triangles. It's all connected. Now, we haven't started talking about radians yet, but we're going to. But in this first part, I just wanted to see and show you where do some of these numbers start to come from. So start to memorize it, even though you don't know all of it yet, and I will talk to you